Okay, today we are going over Chemistry 1306, Molality, percent by mass. For some reason, this kind of gets people a little jumbled up. I want to just clear the air and let everybody know how exactly this works and know that we are actually dealing with percent and molality. So I have a question right here, but I want to go ahead and show you that molality, it deals with the kilograms instead of the liter. So it'll be 1 mole over kilograms as opposed to 1 mole over liter, which is molarity. This is little m, molarity is big M. Molality, molarity. Molality. Molarity. So this is little m, not big M, little m. So let's go ahead and go through the question. So calculate molality of 41.5% by mass of an aqueous solution of sodium chloride. Aqueous is a mixture, so it's, say sodium chloride is in water, it is something that's already dissolved in something. It's solvented is what they call it. So let's go ahead and begin. So we have NaCl. First we need to go ahead and get the moles of that. NaCl is equal to 58.44. Now we are going to deal with this being the amount of NaCl we have. The rest of this percent, when you think of percent, think of it percent, like per 100. So if something is 50% off, then you get 50 of it you have to pay, basically. So here, let me switch color. If I have 41, I need to get the molality, 41. So I have 41.5% of mass, right, of NaCl, parentheses. And I'm going to multiply that by my conversion factor of 1 mole over 58.44 grams, basically like grams per mole, but we'll put grams. And so here, think of it as it's a percentage, but since we're doing it at 100, you can automatically do it just as grams. Cancel, cancel. Left with moles. So from here, we'll go ahead and calculate that, and it will be 0.710 mole. Now we need to find out our kilograms, or our kilograms. So we'll go ahead and go through the process of fixing our H2O. Now notice it's 41.5, so what is the rest of the 100? Minus 41.5, right? It will be 58.5. And when we create that into kilograms, you could do the conversion factor of putting it, doing the whole multiply times with, or divide times 1,000, but I just like to move the decimal point, And kilo, whenever I think of kilo, I think of a kilometer, so it's a very large number. So if you're going to have this, it's a very big number, so to turn it to grams is actually going to put it to proportion size, or a little bit better. So we have 0.058, see, of H2O. Now let's bring this up because we need the molality. We need the mole over the kilograms. So from here, 0.710 over 0.0585 H2O and NaCl. And from there, we get our answer, which is equal to 12.136. And that's our molality. Okay. Now I'm going to just do one more just so you can see it real quick. Say I had, say I had 40 Can you see? There you go. Say I have 44.3 grams NaCl. I'm just going to do it real quick so you can see that it can be done. I'm putting, this is actually my mass. I got this from adding sodium to chloride from the periodic table. Just in case you don't quite remember that from 1305. Now I'm equaling it out to 0.7580, and that's mole NaCl over, and then my water, of course, it's going to be, it's by percent, so 44.3. That is going to equal me out to 55.7 grams. You probably move that a little bit more that way so our decimals can line up. Is equal to, and then we need kilograms. So I'm going to just move the decimal point because these are easy circumstances in which I can move the decimal point pretty easy. Kilograms. So I just put this under this, 0.0557 kilograms, and with this it's being divided, so my answer will be concluded at 13.6 moles per kilogram. And there you go. Let me go ahead and zoom in just for a little bit so you can see. But that's the situation. You get your moles and then you just put it over the remaining amount of the percent.